Thank you, Kathleen, and especially thank you to Justin and Patty for inviting us to talk today. I'm really excited to be here. And thank you for coming out. I know that everyone's favorite way to cap off their workday is with another PowerPoint, so I appreciate you sitting here, listening to me, letting me talk at you for a minute. I'm going to talk a little bit about DevGlobal, the organization, talk about some of the work that we do, since services firms can kind of be a little ambiguous sometimes, and then dive a little bit more deeply into one of the projects that we've been working on over the past year that I think will be particularly interesting to this crew. But first, I'll introduce myself. So as Kathleen said, I'm James Heathcoat. I'm a principal consultant in our geospatial practice area at DevGlobal. I'll talk for just a minute about how I ended up here, because for me, this is kind of a funny journey. It's a little bit of a circle. And as I'm saying that, I kind of realized that no one wants to describe their career trajectory as a circle, but I'll hopefully I'll explain that, and it'll seem a little bit less detrimental. So I cut my teeth in the defense arena. I worked in geospatial intelligence for about 10 years, started off at the University of Missouri in the Center for Geospatial Intelligence, where I was introduced to my first federal contract, some of the applications of geospatial technology to different problems that we were trying to solve at the time. Which are fun because I can't talk about it, and I'm sure many of you know how that goes. Then I spent about 10 years in that domain, so worked for not Harris anymore, L3 Harris. It was Harris when I was there for about 5 or 6 years, and I did a stint at the Defense Information Systems Agency. But most of that work was focused on geospatial intelligence. So I worked on large content management projects for NGA, got to spend some time in research and development, building machine learning models, worked in large vector data set automation, attribution automation, and really kind of fell in love with the technology, fell in love with the work, the problems that we were solving, doing things better, faster, more efficiently. Kind of during that time, though, I also started to think about the implications that some of the work that we were doing could have in the global development space. And this is especially towards the end of my career. Or not end of my career, I don't know what I'm talking about. Towards the end of my defense career, we'll say, where I started thinking, some of these technologies could be really impactful if used for global development applications. And I think that's an easy thing to see when you're kind of in the domain, is like, this data set would be really helpful for emergency response, for example, or this technology would be really useful for planning vaccination or vaccine distribution across the globe, but didn't have a lot of visibility into that space. So about a year, actually, a little over a year and a half ago now, I came across a job posting for DevGlobal. I never heard of the organization before, but it very much aligned, when I read about the work that they were doing, it very much aligned with kind of where my head was at the time, applying geospatial technology to global development and humanitarian problems. So I applied for the job, started working with DevGlobal, and have been with them ever since. And so I say that it's kind of a circle for me because throughout my defense career, or GeoInt career, I kept thinking, I need to get plugged in at T-Rex. We should really get plugged in at T-Rex. And I brought it up so many times. So it's funny that now that I've kind of switched out of that domain into the global development domain, I'm here and we're actually plugged in and we're a partner with T-Rex. But really, really excited to be here and share a little bit about our organization with you. We'll see if I can get my slides to advance. Yeah, we're technologists here. We can use PowerPoint. All right, there we go. So who is DevGlobal? Really simply put, DevGlobal is a services firm that operates at the intersection of technology and global development. We work with some of the world's largest NGOs, nonprofits, multilaterals, government agencies to democratize geospatial technology in the global development domain. And we actually have three. We're a distributed company. We're kind of fully remote, but we have three kind of presences globally. We operate in continental U.S. We also have our partner company, DevAfrique, operating out of Africa, primarily located in Nigeria. And then we have representation in India as well through our Dev India partnership. So in terms of who we work for, some of these logos you'll probably recognize, and I won't talk about all of them. And this is just kind of a picture of our network here. But we get to work with a lot of really cool organizations. Like I mentioned, some of the leading nonprofits, NGOs. Carter Center, we just started up, we didn't start up. We're doing a follow-on project with them right now in partnership with their guinea worm eradication program. We do a lot of work with the Bill and Melinda Gates Foundation, helping them to apply geospatial technologies across their portfolio, across their program of activities. Let's see, who else we have? Jane Goodall Institute, we just started a new project with them to help them modernize their data management practices for the geospatial data. So a lot of cool organizations. Hope to add to this list, but it's also much larger than I've actually shown here. Within kind of our our business ethos, there's a few core principles, and these seem maybe a little bit ambiguous, but I'll try to describe them as best I can. So I mentioned democratizing technology already. What I mean by that really is we are taking a model where we are attempting to bridge the gap between technologists, private sector, and implementers and users in country, the impacted communities. So we're trying to make technology accessible to those communities in a sustainable way. And by that I mean, we don't want ourselves to be a part of the equation forever. We want to enable implementers, enable in-country users in communities to use these technologies without needing us there. So that takes the form of accessibility sometimes. Sometimes it takes the form of improving technical literacy within different organizations or communities. But basically, we're trying to we're trying to take an approach on geospatial technology that allows us to remove ourselves from the equation after helping organizations, groups, and communities to get started. Bridging divides. I think one of our greatest strengths is in our convening power. So we're very well connected within the global development community, but a lot of us come from the private sector. We've got representation from Maxar. I mentioned I was at DISA and L3 Harris. We've got people from Microsoft. So we're able to talk across those boundaries between the global development space, the implementers, the humanitarians, and the technologists, the commercial side, and make sure that the conversations that need to happen are happening and that humanitarians have the resources and technology that they need to be impactful. And then the last one, disrupting with intention, again, kind of ambiguous, but really that is just to say that we are looking for opportunities to do things better, and still general. But a lot of these organizations, especially when it comes to the public sector, are doing things the way they've always done them. And so we're very intentional about looking for opportunities to do things more efficiently and breaking the mold of how things have always been done to maybe do things better, in pairing that with our ability to hook them up with private sector companies and new technologies. Focus areas, I'll touch on this just briefly, just for the sake of time, but one of the things that we're also interested in is making sure that we have a broad perspective. So we have a lot of geospatial talent within our organization, but we also don't want to operate in our own kind of geospatial silo or look at these global development and sustainable development problems from just the geospatial lens. So we've pulled in experts from agriculture. We've got experts from global health that have worked in the field for a long, long time and can inform some of the decisions we're making about how technology is implemented, how it's utilized, how it's deployed across the domains. So what does that look like? Like I said, a lot of services firms, the work can be kind of ambiguous. You can list all these different things that you do and things that you offer, but where does the rubber meet the road? So I'm going to talk a little bit about some of the projects that we've worked on recently. And then, like I said, I'll dive into one in a little bit more detail. Working with the Carter Center right now, this is a project that I am directly involved with, supporting the technology development. Working with the Carter Center on their, what they call the GWEP program, the Guinea Worm Eradication Program. So historically, the way that this program had operated was they send abate team members. Abate is like the chemical that they use to actually treat small water bodies for, guinea worm copepods. They send these teams out into remote Ethiopia to find these small water bodies, just meters or even less than a meter across, to treat the water bodies to test and to treat the water bodies for the guinea worm copepod. The guinea worm virus is often transmitted via baboons, spreading it to water sources that are spread to local dogs, which spread it to the villagers. So one thing they needed support in was first recognizing where all of the water bodies were within their region, that were both within the baboons' range or territory, and were also within the typical wandering range, I guess, of the village dogs. So we could understand what the impact was of treating these water bodies on the spread of guinea worm. So we actually worked with Maxar, who generated water body detection outputs using SAR data and elevation data, and then generated standardized maps for the teams that had previously been going out into the field with just a compass and like a printed screenshot of the area to try to find these locations and identify them. And then they were to track how they were actually treating them, or when a water body was treated, they were writing down coordinates with a pencil and then writing the status of the water body. So another thing we're doing for them, and we're kind of in the final stages of this right now, is building them a better way to navigate. So instead of GPS, compass, paper, we've built them a mobile application that operates offline so that they can navigate to the water body detections, update the information about the water body to a centralized database, and then can track their progress locally. Another project that we worked on recently, I mentioned kind of our convening power, the ability to bring together the people that need to be talking. So one of the things that we did over the course of the COVID-19 pandemic was to establish a working group in partnership with the World Health Organization and UNICEF to start talking about how we can effectively deploy digital microplans for vaccination distribution planning. So a lot of times that involved assessing the available data sets, talking about gaps in the ecosystem, where we might need to improve data, how we can effectively deploy campaigns, but then also bringing together the technologists required to do this effectively with the implementers, with the World Health Organization and UNICEF who'd actually be deploying these campaigns. Accelerating energy equity. So this one was done a little while ago, but with our kind of broad perspective of the field, of the global development field, especially as it relates to geospatial, we were able to perform landscape analyses pretty effectively. So one of the things Microsoft wanted to know was, what are the gaps in energy equity? What are the gaps in sustainable energy development projects? So we were able to go basically interview a lot of people from the global development and renewable energy space, and then consolidate that report back into something digestible for Microsoft to see where the data gaps were, and then take action to address those. And that leads me into one of the projects that I'm going to spend a little bit more time talking about, and is something I've worked on very closely over the past 2 years, which is RAMP. The name is, I didn't come up with it, so if you hate it, it's not my problem. Replicable AI for microplanning. I love acronyms in acronyms. A little closer. Okay, there we go. All right. All right. What is RAMP? And I anticipate there will be questions about this, so feel free to hit me up about it. But RAMP, very simply put, is an open source machine learning model for extracting building footprints from high resolution satellite imagery. And when I say that, I know that many of you are thinking this has been done before, and it has. And we are under no illusions that we're the first people to do this, or even that we are doing it the best. But one of the problems, especially in the global development space, is just catching up to where industry and the private sector are. So our focus on this project was not on necessarily building the most cutting edge or innovative model. If you're interested, it's a semantic segmentation unit with an efficient net encoder. But we didn't really care too much about the underlying methodologies. Our focus rather was on making sure that technologies that already exist within the private sector, that exist within the federal sector, are accessible to the communities that need them in a way that allows them to deploy it and not require a dependency on commercial entities. Key partners on this. So this was actually funded by the Bill and Melinda Gates Foundation, but we worked closely with the World Health Organization to kind of guide our approach, since our initial kind of application for this was digital microplanning, especially as COVID was at the top of everyone's minds. We also worked closely with our DevAfrique partners for in-country cooperation and acting as our champions in Africa. I mentioned that we try not to work in a vacuum. So we pulled in very early in the project, we pulled in, excuse me, we pulled in advisors from a lot of different organizations that we had relationships with to make sure that we were not just contriving this. I mean, we could see the value of building footprints in the global development space, and we thought we had a clear path to value here, but we didn't want to just make that assumption, execute on it, generate it, and create something that wasn't usable for the actual implementers, for those doing the work. So we partnered with different consultants or different advisors from across Hot OSM, Grid3, ID Insight, and many others. And I'll highlight 3 of these because I think they're particularly important. Radiant Earth Foundation actually was a great technical partner on this. They host all of our training data, all of our baseline model weights or pre-trained model weights on their Radiant ML hub, so it's all open and accessible. And they do a great job of formatting that into stat compliant formats. Takadam was a partner. Actually, the company itself is made up of refugees who are doing data labeling for machine learning models, and they actually did a lot of our data labeling, and that relationship was kind of managed by the Radiant Earth Foundation. And then Development Seed was a technical partner on this, helped us to write some of the code, but also helped us to find ways, excuse me, to deploy the code in a way that's a little bit more approachable. So why buildings? I think when we looked at this, like I said, our first thought, because we were working with the World Health Organization, was digital microplanning. How can we effectively plan vaccine distribution when census data is old, it's outdated, when resources like OpenStreetMaps are kind of sporadically updated based on campaigns? We need reliable and temporally accurate data to be able to make these decisions. So we recognize that value there. But there's also a lot of other applications for this. And this is kind of why this was such an important project for us. Was it's something basic. It's a building footprints. It's a machine learning model that's not terribly new or exciting, but it's critically important for a variety of global development problems. So while our initial focus was on global health, we thought about the implications for climate resilience, disaster response, renewable energy, which we'll actually talk about because we did some recent work there with the RAMP model. But across kind of the breadth of the global development space, building footprints, especially temporally accurate building footprints, are critically important. So there's a few challenges in the public space when it comes to models like this. The first of this is imagery acquisition, just access to high-resolution imagery. It's often very expensive. It can be cost-prohibitive, especially to in-country implementers where they need to deploy these types of models. And sometimes just the process of acquiring it can be kind of arduous. I can't say that we've solved this. I think this is still one of the greatest challenges in the global development space, is finding affordable access or reasonable access to high-resolution satellite imagery. But our approach to this was to use open source imagery to train the model, to test the model, and to make it replicable for anyone that's interested in using it. Outside of that, though, just beyond using accessible data, and I should mention that the imagery that we used was from the Maxar Open Data Program. Rhiannon Price, who is our Chief Strategy and Innovation Officer, actually helped to start that program at Maxar. But outside of just providing the data that we used and making sure that we used open data, we provided a lot of documentation and information for NGOs, for the public sector, to go and create partnerships with organizations that have access to high-resolution imagery, and to find ways to acquire it for themselves. Training data. If you've worked with a machine learning model, you know that this is critically important and terribly painful often. So as I mentioned, we used Takadam, our partner, to help us with the training data, and we actually manually curated about 1.2 million building footprints for our training data, which made up about, I think it was a little over 100,000 training chips, so label image training pairs. We made all of those publicly accessible, so they're all generated again from the Maxar Open Data Program data, and then they are all stored right now in Radiant ML's hubs, or Radiant Earth's ML hub. Hardware and environment. This one was a tricky one for us. So model has to be trained, has to be deployed, you have to be able to run inference somewhere, and oftentimes, especially when training a computer vision model, it's pretty resource intensive. You need high-speed GPUs. You need actually a moderately sophisticated compute environment to do that. And with the intention of making this accessible and replicable for our in-country partners and for the implementers and users, we had to really think carefully about the hardware requirements of the model that we were developing. So we designed it to be lightweight, so it would require minimal compute resources. We actually were able to train it successfully on a laptop. It just needs a CUDA-enabled GPU, NVIDIA GPU. But beyond that, we also worked with our partner DevSeed to build a deployment of the model that works on Google Colab. So initially, we had started looking at things like AWS or some kind of other cloud platform, but that can become, again, really expensive for some of our in-country users. So we developed a deployment that runs on Google Colab. It's fixed costs. You can upgrade to like the pro tier for like $10 a month. So it's really still approachable for our in-country implementers to deploy. And you can train the whole thing on that $10 a month tier, and you can actually run inference on the free tier with no issues. Model development. One of the things we had to consider when we were looking at making this accessible to in-country users was that the technological fluency was not going to be the same across all of these implementers. So we wanted to make it really approachable from the sense that you don't need a data science degree to be able to deploy the model or to train the model or to actually generate outputs from it. So we focused really heavily on documentation. The RAMP website has very detailed documentation on what every script in the repository does, how to deploy it, how to set it up on Google Colab, how to set it up locally, and then how to evaluate your outputs and make sure that they're actually valuable and performant. I'm lagging behind with my slide switch as I get talking and I forget. Sorry about that. And then building digitization. Obviously, this is kind of the goal, but the challenge in the space is that they are spending so much time. If you want building footprints, you have to spend a lot of manual effort to actually draw the boundaries around these manually to get any real use out of it. So the idea is that they would be able to deploy this and cut that time down and then further free up resources with communities and implementers to actually do the work, run the campaigns, and have the impact that they're targeting. The other part of this is that we released not only the kind of model architecture or the approach, but we released the pre-trained baseline models, and I'll talk a little bit about that as well. And then decision making. One of the biggest problems that we've faced in the global development community is just building trust in outputs, especially where this is something that's new, it's something that hasn't been done, and you run a model and it gives you some kind of output. How can you know that you can trust that for for analysis. How do you know you can trust that to get an idea of where your population or your community lives? But by putting these tools back in the hands of the implementers, back in the decision makers, the people that are actually running these programs, they see the process end to end and they know that they can trust it and they have more agency and ownership in the process. So what does the RAMP project actually include? So as I mentioned, we have a full code base with really detailed documentation. We really drilled in on this because we don't want it to just be accessible to data scientists. We want someone with any moderate amount of technical acumen to be able to run this. So I'm not a data scientist. I have some experience in the domain, but it was very easy for me to get in there with primarily just a geospatial background and say, I know exactly what I need to do. I can follow the steps and I can execute this. Label data, I already mentioned 1.2 million buildings labeled on high-resolution satellite imagery. The vectors, the masks, and the image chips are available through Radiant ML Hub. We developed a number of production tools like our mask generation tool, data preparation, tiling tools so that you can actually prepare your data and make sure that it actually operates with the model and operates efficiently. Training materials, we went all the way back to kind of even our labeling practices, making sure that we had consistent labeling practices prior to training the model to say this is how we do things, this is how we make decisions to make sure it's consistent as we're looking at these inputs to the model. Data management and efficiency tools, we developed this one tool called, we call it Chippy Checker, but basically it allows you to flip through tile or through labeled data really quickly to either reject it from your training set or to modify it to make sure that you have consistency across it. And that was very critical in looking through that many buildings. And then our model card. So one thing we tried to emulate was Google's approach to model transparency. So we did an ethical review of the model, what the implications were for releasing a model like this publicly or a framework like this publicly, what how it could be used improperly, and then made a decision based on that analyses of whether it was worth the risk to publish these tools. All right. And then finally, I'll just touch on some recent work that we did with this project. I'm actually wrapping this up right now. We were approached by a team working in Kosovo on a renewable energy project, so the Kosovo electrification project, where they are assessing the solar suitability of residential rooftops and identifying ideal placement for solar panels. One of the required steps really early on is to just delineate the building footprints. And so they came to us and they said, we spend most of our time on this project, not necessarily actually planning where the solar panels go, but rather just outlining buildings. And so again, it's like a really simple implementation of a machine learning model, but it's really critical because it doesn't exist in this space in the public sector. So we took actually, we got on this slide. Okay. So what we were able to do was we helped them prepare their imagery. They had drone imagery. It was like 2-centimeter drone imagery. Our models were trained on 30 to 50 centimeter high resolution satellite imagery. So we resampled the drone imagery to meet the criteria to the 30 centimeters. We tested our pre-trained models on the data, and it actually performed moderately okay, but the process that we've envisioned for RAMP is not that you would just deploy the baseline model out of the box, though that might be sufficient in some applications, but rather use a small amount of local training data to fine-tune it to that location. Then spent some time improving the labels. So we noticed there was a big inconsistency in how their data was labeled with how the label data that we created for the RAMP project was labeled. So I spent a little time making sure that it was consistent, extracting commercial buildings that perhaps they weren't interested in for the solar analysis, but they were things that our model had been trained on. Then we used some of the building footprints they generated from their previous efforts to fine-tune the model. And then actually one of the other data sets that we have hosted on Radiant ML Hub is our Open Cities data set, which was kind of the same thing. It was 2 or 3 centimeter drone imagery. We resampled to 30 centimeter. And we actually hadn't included that in our baseline model training, but I was able to pull from that to continue to fine tune the model on a similar data type. And we actually saw a really significant increase or improvement in the outputs for that. And then generated outputs and provided the model weights and some kind of documentation specific to their project to the KESS team. So how did it go? So this is honestly one of our earlier work. It's one of our earlier projects where we worked from start to finish through the RAMP model and actually got to test it ourselves beyond just like the initial project beyond the development of the project. So there was a couple surprises. Building footprint outputs were actually really, really good, especially when we use the Open Cities data. So we know that we can get the model to, maybe this is contradictory, but we can get it to generally localize pretty well, and we can see really good performance out of it. And I don't know, it's probably not visible on the screen. You can see the green lines there are the original labels, and then where there are blue hashes across it, that is our actual building footprint detection output from the model. Another thing we noticed were the accuracy scores were actually really low, and so when we actually did when we did the accuracy analysis on it, it was like 75% or something, or F1 scores were like 75. And I was a little bit concerned. I was thinking I thought we were going to do a lot better than this. But what we found was actually it was mostly in a labeling discrepancy. So we were capturing small buildings that are not terribly critical for solar analysis, and then also, like I mentioned, the large commercial buildings. So there's a discrepancy there that kind of misled about the performance of the model, because it doesn't matter if we extract those for their purposes as long as we also get the residential buildings. And I already talked about the supplementation with the Open Cities data. But we just had our project wrap up last week, and the chief technologist for the KESS program said that the model outputs exceeded their needs for the building outlines for the solar suitability analysis. So we're actually doing some follow-on work with them right now. But it was a really cool project for me, having been involved in the development of it, to actually work through a real-world problem and see kind of what the outputs were and how this would be utilized. Hopefully I'm moderately on time, but that pretty much wraps it. I know that was all over the place, and I talk really, really quickly. So if I breezed over anything, feel free to ask questions. But thank you again for letting me talk at you for a little while.
Got something, but we want to make sure we get it on the mic. Okay.
I'm just curious what your process is for finding and or choosing the jobs and the projects that you guys take on. Do you have more than you could do and you have to choose, or do you solicit, or how do you guys go about finding your projects?
That's a great question. So I probably don't need to state that there's plenty of need in the global development community, especially when we look at some of these large sustainable development projects. So when we're looking at selecting projects, we look at it through kind of the lens of the ethos that I painted before. Are we going to help to transfer technology to the users in a way that's sustainable, or are we positioning ourselves as a middleman where we are required as this mediator to continue to either supply tools or resources to a community? So is it something that's going to be sustainable? Is it something that we can hand off and remove ourselves from that and it will live on? That's an important consideration. The other consideration for us is, right now, as we're still kind of a growing company, is we have to balance our impact with our sustainability. So there might be decisions that we have to make that, we can apply the technologies and the tools to a larger program where we might not be as directly involved as the impact as we'd like to be. But then we're also going to find those opportunities where we get to kind of touch both sides of that. It's something that provides sustainability for us and consistency for us, but also we can be directly involved in the impact. So we're looking for places that we can see the direct impact. We know that it's not just consulting work, for example, or providing some kind of echo chamber to a group that already exists. And we're looking for opportunities that we can remove ourselves from. And that might be really counter to business development statements in general, but that's kind of the thinking.
So one of the things you were talking about when you first developing the model is using your Maxar data for training, and then I was wondering kind of what modalities you'd be able to use downstream. Then you came on to Kosovo. So upscaling from 2 centimeter to 30 centimeter data, I would imagine there's a big discrepancy in look angle from your Maxar satellites versus your drone data that's 2 centimeters. Did you do anything to correct for that, or was the original drone data captured at similar look angles to what the Maxar satellite's coming in at?
Surprisingly, the look angle was moderately similar, like it was almost on nadir, but I didn't do any kind of modification for that. I didn't do any pre-processing that, specifically because I wanted to see how well the baseline models could retrain, especially when the modality was a little different or when the domain was a little bit different. So my thinking going into it was, I'm going to resample this, but other than that, just so it's consistent with the architecture that we have. But other than that, I'm not going to touch it because I want to make sure that with I think it was around like 2,300 labels that we were going to fine tune the baseline model with. I wanted to make sure that that was enough to actually learn some of those differences between the satellite imagery we trained on and the resampled drone imagery. I did find that there were some differences in the ways that I resampled. So I used cubic spline resampling, and I found that that was the most representative of some of like the atmospheric distortion that you might see in satellite imagery. But other than that, I was really testing out, can we actually make the model understand this different data type with just a small amount of training data, and it worked pretty well.
Thanks.
This is a bit of a broader question, but how does DevGlobal negotiate or navigate the contradictions or problems between developmental goals and humanitarian goals, and the various the short-term immediate needs-based goals that are in humanitarian work versus the long-term political goals that are in development work?
I think our approach to that really just comes from pulling in the right people. So we want to have experts in country. We want to have people on the ground, people from the community, the implementers that can really speak to the needs of that community. Because again, we don't want to be operating and making these long-term sustainability decisions above that level. We need to be informed at all those levels. So bringing in local experts, bringing in community members, the implementers, and most importantly, the people that are going to be impacted by the decisions that are being made, and making sure that there is a line of communication between them and the larger implementers or larger organizations like the Gates Foundation, like the World Health Organization, who are actually trying to act on their behalf but need the inputs locally. So I think that's how we approach that, is making sure that the right representation is there to make these decisions in an equitable way.
Might be it. I also just want to, what a cool QR code for questions. So if anybody else has them, let's take that down later. Oh, got a question over here. Good. Okay. Sorry. We want to get this on the video though. So.
Yeah, I had a quick question. When you were looking at the satellite imagery and looking at your chip chunks, obviously, were you guys annotating the chip chunks separately at like 500 by 500 pixels? I'm assuming.
So we chopped them up into 250 by 250 pixels, but we actually did our annotation prior to that because we needed the contextual information to know if a building just barely overlapped or,
okay.
And just it helps our analysts because you don't really know if something's entering the chip, if it is a building or not.
I was going to ask you about that. Did you guys actually, when you sent it through the model, do you have overlap of the images?
So there's no overlap. No, there's no overlap is the short answer. But the way that we are doing, the way that we're generating our masks for training is we're using 4-channel masks. So we're not just marking building, non-building. We are marking building interior, building boundary, non-building, and then building adjacent. So lines between buildings. And that helps to build the context of what's around an individual chip without necessarily needing the overlap. And then we have a post-process to actually stitch the outputs back together. And make sure that they're consistent.
Oh, interesting. Okay. That makes sense. Cool.
Okay. Looks like it wraps it up unless I'm wrong. Okay. Thank you so much, James. This was really awesome.
Thank you.
Once again.
Happy to talk.
Thanks.